Understanding and Implementing MGCP Part 2. You've now seen the messages that MGCP uses when it's communicating with gateways, how the call agent is able to control the gateway and instruct it what to do. You've seen some of the call flows, and now we can start moving into some of the practicalities, like things you can take with you and implement in a voice network. First thing I want to do in this nugget is talk about MGCP backhaul. One more concept for you. And that's going to be where we are using MGCP to control ISDN lines. And I know if you're coming from the data world, you're probably thinking, ISDN? Where do we use that anymore? Well, in the data world, we don't really too much use ISDN. But in the voice world, it's all over the place. So I'll talk a little bit about that on MGCP backhaul. We'll then look at MGCP port descriptions, because when you configure this, you're going to see these MGCP ports show up in the call manager, and you're going to look at it and go, well, what is that funky description? You'll want to know what it is, of course, not only for the certification exam, but so that you can look at these descriptions and have them make sense to you when you're configuring a call manager. Then finally, I've got multiple MGCP configuration scenarios to walk through with you from the gateway and the call manager perspective. Well, let's start things off by talking about MGCP backhaul, which is a configuration and a concept that allows your router and call manager to split the configuration and control of an ISDN line. Now, before I even dive into that, let me just take a moment to talk about ISDN, where that comes into play, because as I mentioned on the objective slide, ISDN in the data world seems like one of those technologies that's just not in use anymore. If you're studying for the CCNA or CCNP certifications, you find out that probably a couple of years ago now, they removed all ISDN questions just because it's not that popular of a data connectivity anymore. It's still out there, and sure, the configurations are still there, but it's just not enough of it to really justify all the learning that has to take place. So in the data side of things, ISDN is kind of like a I still don't need it kind of technology. Like I don't use that anymore. But in the voice side, it's all over the place. The ISDN is necessary because ISDN, and I'll specifically say PRI connections, is where you have those 23 voice bearer channels to send the voice, and then one signaling channel, I'll just call it the D channel, that is used to send signaling information like caller ID, like feature support, all kinds of stuff gets sent over that D channel in the voice world. Now, in the data world, it didn't make sense to waste a whole channel for signaling. Come on. I mean, let's use CAS and get a little more bandwidth that we can use for our data. But in the voice world, that makes a lot of sense because that's where we pass our features. So you'll see a lot of PSTN connections being a PRI link, where you get 23 channels rather than the full 24. Now, there are CAS connections, and we'll talk about the configuration of both CAS and PRI over the course of this series, but I would say by far PRI is the more popular way, especially, and I don't even show it here because we have a whole nugget later on about it, when connecting to PBX systems. PBXs, back in the day, came out with this language that they could use called QSIG. I think I already mentioned this in one of the previous videos, but I'll mention it again. Q signaling is what that stands for, and that language allows PBX vendors to communicate some features between vendor lines. So if I've got, vendor A up here and vendor B down here, they're two totally different vendor PBXs, QSIG was the protocol that they could use to talk. Well, MGCP backhaul is the only way that you have to support a QSIG connection. Meaning, here's your scenario. You got a PBX system in your organization, 500 phones that are working on it, and the organization has said, we want to move to voice over IP, but we can't just get rid of all 500 phones all at once. We're going to do it in a phased migration. We'll do maybe 100 phones at a time. Well, you set up your first 100 phones over here, and you set up a PRI link between that router and the PBX system with a QSIG card or in QSIG support in that PBX to where it now supports Q signaling between them. Now you can do transfers from these IP, here's your IP phones on this side of the world. You can do transfers from the IP phone to the digital phones on the PBX, put one of them on hold, call to them, all of the features, or the major features I should say, are now communicated between the router and the PBX system using Q signaling. Now let's talk about MGCP backhaul. The router doesn't understand QSIG. let's put that little piece of the puzzle in there, right? The router doesn't understand it at all. All it knows is it's got a link a T1 line or a PRI connection over to this PBX. MGCP backhaul allows the gateway to handle Q.921 signaling. Now, if you've played with ISDN in the past, you might recognize that and may think like LAPD, Link Access Protocol, D channel. You know, there's all kinds of different signaling that happens. But overall, the way I always remember it, when you see Q921, just focus on the 2 and think layer 2. That's your data link. Your data link signaling. So that handles things like, you know, this router telling the PBX system, hey, I'm not ready to receive, or I'm ready to receive now. You know, maybe you swamped me with information, or I'm rejecting that message, or I'm disconnecting this line and tearing it down. You know, all that, when you think layer 2, I mean, that's what you think of, right? Just simple, like, I'm connected, I'm not connected, okay, send, okay, don't send. Just very simple, let me control the almost physical aspects of this connection to the PBX. But when this PBX comes over and says, hey, using QSIG, I've got a phone over here that's transferring a call to this guy, to this IP phone on the other side of the network, well, the router doesn't understand that. It's Q signaling. The router doesn't support Q signaling. So what MGCP backhaul does is the router gets that message and passes it to the call manager using Q.931. And again, 31, think network layer, layer 3 of the OSI model. Q931 is where that QSIG signaling resides, and the router says, I'm not taking responsibility. I handle layer 2, the call manager handles layer 3. So it splits the processing of that. Now, it doesn't have to be using, I just used QSIG as an example. It doesn't have to be using QSIG. It can be, you know, just a standard PRI line to the PSTN, and it does the same thing. The router will handle the layer 2 processing, layer 2 physical style connections, and connect, disconnect, you know, accept messages and things like that are coming from the PSTN. But all of the actual, like, caller ID information that gets sent, you know, using Q931, the disconnect message from the phone itself, you know, all of those kinds of things gets passed to the call manager so it can handle it and forward the calls appropriately to the IP phones. So to summarize, MGCP backhaul allows you to pass the layer 3 signaling, or I guess you could call the control of the PRI connection to the Cisco call manager. And that's why you'll see MGCP used quite a bit to handle PRI connections, and you have to use it when you're handling QSIG signaling. Now, we're staring at Call Manager. It just kind of popped up randomly at this point. The reason I brought up Call Manager, this is Call Manager 6.1, is because I want to show you the configuration of an MGCP gateway in the Call Manager, which will lead me into the port descriptions, which I was talked about on the objectives, where I said sometimes these port descriptions can be pretty cryptic. So let's configure an MGCP gateway. I'm going to go to the device menu, shoot on down to Gateway. And it shows as of right now I've got one gateway, this H323 gateway. This is actually well, let me explain. This call manager, let me even back up further. I am a complete Cisco fanatic. And in that sense, I installed a complete voice over IP system in my house for Cisco. I've got Cisco IP phones to make calls. I've got a Cisco 2800, 2801 voice gateway that connects to the PSTN and converts my voice over IP when I want to dial out to the PSTN. So this call manager that you're seeing here is actually, I guess you could call it a production call manager, but I'm going to mess around with it because it's for my house. And if my home phone lines go down, oh well, you know, who calls me at home anyway? No one. They call me on my cell phone. So, anyway, I've got one voice gateway. This is what actually is running my house right now. I'm going to add a new one in the upper left-hand corner. Click on Add a New, and you see this drop-down appear of all these different Cisco routers that you have, and you can choose your model number, and you can also see down here VG248, that's our FXS gateway, and two more down, you see H323 gateway. If you want to use H323, and I'll come back to this when we get to the H323 nuggets. This is how you add an H323 gateway. No matter what model of Cisco router you have, you can have a 2800, an 1800, a 3800, a mother of all Cisco routers, and it doesn't matter what model it is. If you want to use H323 to control it, use H323 gateway. So that begs the question, well, what's up with all these? I mean, why would you pick the model number then? Well, if I wanted to pick the model number, like let's say Cisco 2801, and hit Next, you'll see that the only protocol it's giving me is MGCP, That's the protocol in question we're talking about right now. Or you can use Skinny, the Skinny Client Control Protocol, which is very rarely used to control gateways. That's what we use to control our phones, our voice over IP phones, using Call Manager. So I'm going to choose MGCP. Again, if I wanted to control 2801 using H323, I would have chosen H323 gateway. So I choose Next. Now, because I'm using MGCP, all of the configuration for that gateway, all the intelligence of that gateway comes in this Call Manager. So it's almost like a step-by-step config we're going to do here. Domain name is going to be the name of the router. So I'm going to say this is, well, hang on. Let me bring that voice router into the picture. There we go. We got the 2801 voice. That's the name of the router. So I'll copy that over to the clipboard. Minimize, paste that in. It has to be, it's case sensitive, has to be exact. So it says the Call Manager group, that's part of the CIPT course. Go get the CIPT series. That's going to be where we talk about what call managers are going to be supporting this gateway from our cluster and so on. Then I'll go down here and it says, what module do you have configured in slot 0? Well, the 2801 router is unique. I love it. This is one of my favorite routers because it actually has on the motherboard, you see MBRD, on the motherboard, the capabilities to handle voice modules. You don't have to buy voice carrier modules like NM2Vs or NMHD2VE carrier modules like you do for all the other Cisco routers like 2600, 2811. All those have to have carrier modules for this. This guy doesn't. It has it built in on the motherboard to support voice cards. So in here it says, well, what subunits? These are the 4 modules or 4 VIC/WIC slots of the 2801. And I'll say, well, in let's say in subunit 1, I've got a VWIC 1MFT T1 card. That's going to be just a T1 line that can be used for CAS or PRI. I click on Save, and it's going to pop up right here. This little it says, okay, well that is going to be module 0, card 1, that's subunit 1, and then port 0 on that card. Do you want to configure it? That's what this little mini question mark here is. So I click on yes. I'll click on that question mark, and it says, is this a T1 or PRI line? I'll say it is a PRI, and this is where we go through and start setting up the configuration of that PRI line for this, and we can set all kinds of stuff. Scroll down through all this configuration. But I want to stop right here for now because I want to show you. You can see this description that popped up. S0/SU1/DS10 at 2801 voice, and it's kind of like, well, I get that, it's 2801, but is this like a DS1, a T1 line? What is that description? That's where I have this. Understanding the port descriptions. All MGCP managed ports have cryptic identifiers. For example, you might see one that's like AALN/S0/SU0/1 at voice router, or something it's very similar to the one we just saw on my 2801. So when you see these port descriptions, just use this to break them down. You can see general breakdown, endpoint type /slot/subunit/port. So when I see this description right here, like AALN, AALN stands for Analog Access Line, AALN line. So that would be, for instance, if I had configured an FXS or an FXO port using MGCP, it would have been defined as an AALN. After that, when you see S0, that is the slot number. It's currently installed in slot 0. SU0/1 is, and these are actually 2 separate pieces. SU0 is subunit 0. Then you have the slash, and then this last number right here is port 1. So if I were looking at a router, I would say this is like an FXS. We'll do like a 0/0/1. If I were on the router and did a show voice port summary, that's the port number it would show up as. It's an analog access line, module or slot 0. I usually say module. This is subunit or VIC card 0 in that module, and then it's port number 1. Now just let me draw. Heaven forbid. Let me draw this router. Let's say that this is a 2600 series router. And actually, it wouldn't be, but 2600 series router. Over here, is the module that we can use to install voice cards in. You would get, for instance, and let me draw a little more accurately. Here's our plug on the 2600 series. You've got, we'll say it's a 2621. You've got two fast Ethernet 10/100 Ethernet ports. Then up here, you have your two WIC slots. And it's a very common mistake. People say, oh, well, I'll just put my voice cards inside of those, and it doesn't work. The router doesn't recognize them because those slots aren't geared for voice cards. Because this router does not have any built-in DSP resources inside, like that 2801 router I was just sharing with you. So I was trying to go three-dimensional here. Down here, over on this side, is where you have just that big empty open module. And that's where you can get that NM, we'll say HD-2VE. Voice carrier module, where that will be a carrier module, has a big handle down here, and then it has two slots up here for voice cards. Well, if I were referring to those, let's say I put a T1 line here and a T1 line here, what this would be, if I was referring to this T1 line, is it would be a 1, because this is module 1 of the router, slash, and then this is VIC card 0, VIC card 1. It would be 1/1, slash, and then this would be port 0 on that VIC card. So I'd be referring it to 1/1/0. So this one is some kind of router where it has a module in slot 0. It might be that 2801 router, since everything's in module 0 on that guy. And then it's going to be VIC card 0, and then port 1 on that VIC card. It goes, port numbering 0 and 1. Now, this is a general view of MGCP syntax. And usually, you'll see these kind of descriptions, the breakdown like this, in Cisco Call Manager 4.x is usually where you'll see those descriptions. In some of the newer versions of Call Manager, like 6.x, they do the same kind of breakdown, but kind of shift things around. So what I want you to catch is that the MGCP description will always contain these 4 components, but it may not always be in that order. If this is my example of the analog line, right? Let me slide back in our Call Manager 6.x and take a look at our T1 line. You've got S0, SU1, DS1, 0. Now looking at this description, let's see if I can somehow, I can't. Looking at this description, it's saying, endpoint type, slot, subunit, port. Well, that's not S0 is not the endpoint type. That's the slot. So it's saying slot 0, subunit 1, and then right here, notice, that's the endpoint type. It's a DS1. It's a digital access PRI line, or T1 line is people call it. DS0, DS1. DS1 is the same as a T1 line. And then over here is the port number, that little -0. So the point is not remembering the order of this, memorizing this is going to always be the order, but remembering that the MGCP description is always going to contain those 4 components.
All right. Whoa. Look at the time. I gotta get moving. We've got a lot of configuration to go through. This is our MGCP implementation. You can see all of my configurations in red down here. They're one by one. I want to work through each one of those. So we're going to set up a router and put it underneath MGCP control and link it to a call manager system. Now, before I get going, couple notes for you. MGCP gateways still require dial peer configurations. Now that might be surprising if you've done some voice gateway config in the past, because dial peers are used for dial plans. Like this port goes to this phone number, this port goes to these phone numbers, and you can set up POTS or voice over IP dial peers. It's straight out of the C-Voice series of configuring all those connections to other places using dial peers. So if it's all centralized using MGCP, you might think, well, why do we have to configure dial peers? Seems like double the work. Well, the key is in the parentheses. It's to place the ports under MGCP control, meaning that this is actually what we're going to do. I've got a router, and it's got multiple voice interfaces. We've got an FXS port, and that's what I'll set up first, with an analog phone plugged into it that we're going to put under MGCP control. But it also has, a T1 line that can connect to the PSTN, some other FXO ports, and so on. And you might remember me earlier in the series saying that each one of those ports can be under the control of a different protocol. So I could have this T1 line being a SIP port and then maybe an FXO port under H323. But the dial peers put each port under MGCP control one by one. So we'll do that with the FXS. And I also mentioned don't forget your survivability strategies, or SRST. I'll talk about a little of that in MGCP fallback, but more on that when we get into H323 because that'll set up the dial plan that it falls back on. So this router is connected to a Cisco call manager, and its IP address is, let me see if I can get a quick text window going here, 172.30.100.104. Make that a little bigger. How's that? There we go. 172.30 and some kind of gothic writing there. 100.104 is its IP address. And right below it, I have a second call manager. We'll just say it's .105. And then below that, we've got a third call manager, .106. Now, there's only one actual working call manager that I'm working on, and that's 104. But I want you to see the configuration as if there was a bunch of them, because you can have up to 3 call managers backing up a router. So if one goes down, it fails over to another, and so on. So we'll get that going. Now, as I jump into this config, and I'm going to start off with the foundation setup to put the gateway under MGCP control and link it to the call manager. You might grab a pencil or pen and a piece of paper just to jot down these commands as I go through them, or open Notepad over on the side of your window and jot them down, because there's a bunch of commands I'm going to talk about, and I don't want them to just become a big jumbled mess of MGCP when it's all said and done. So let's start off on the gateway. I've got my voice router, 2801 voice. Now do a show voice port summary. And you can see I've got some FXS ports right here, FXO ports, a bunch of eFXS. Those are actually for IP phones. This gateway is set up as a Call Manager Express router as well. That's from the CCNA Voice series, so if you want more on that, you can check that one out, but you can ignore all those. We're just looking at FXS and FXOs, the physical voice ports. And I have an analog phone. It's actually, I'll show it to you in a second. It's a garage sale phone I picked up for $1 or something like that, plugged in here. I'm going to convert it to an advanced voice over IP device. It's plugged into this voice port. As a matter of fact, you can see it's on hook right now. I'll lift it up, do the show command again. Now it's off hook, so it's actually a phone sitting right next to me that's plugged into that. And I'm going to put that under MGCP control. So my first step is to go into the router and type in MGCP. Inside of the gateway, imagine there being a light switch, and I just turned it on. So now we've got MGCP enabled and running on this router. Now the second thing I need to do is tell it where its call manager is. So we do that by typing in MGCP call agent and then the IP address of the call manager. In our case, that is the 172.30.100.104. Now notice I hit the question mark, and I can specify different port numbers if I'm running MGCP on custom ports, or I can go all the way and type in service type and choose the protocol MGCP and say the version that I'm using is 0.1, which is the one we use with Call Manager. Remember, there are 2 other versions. There's 1.0 and then RFC 3435 1.0. You would think, as they increase RFC numbers, they would say maybe that's like version 1.1 or something. But remember, I mentioned this earlier in the series. There is no killer reason why you'd want to use 1.0 or RFC 3435 1.0. This is the one that Call Manager uses, and that's the one the router uses by default. So I'll back up here and just hit enter, because I want to show you it puts all that in there by default when we do a show run. But that's the command that we do to type in the primary call manager. I'll show you the backup call managers in just a second, but it's a different command than MGCP call agent. So from here, I'm going to go in and type in one final command, and that is CCM manager MGCP. What that does is that says, hey, the call manager, or call agent, I should say, is a call manager. That tells the router you are using a call manager, not just some generic MGCP device, which, since MGCP is an industry standard, it doesn't have to be a Cisco call manager. So CCM manager MGCP says this is going to be a gateway controlled by a Cisco call manager. Now let's bring in the redundant hosts as well. We've got the call manager 104 configured as the MGCP call agent. And now, if I want to add the redundant host, I need to type in CCM manager, redundant host, and you can see what is the IP address of backup host number 1. We'll use 105. And it says, what's the IP address of backup host number 2? 106, and I hit question mark, and that's the end, up to 3. So it's interesting that they have different commands to do this, but MGCP call agent specifies the primary. CCM manager redundant host specifies the secondary and tertiary backup servers that you can have on your network. So that's the gateway side of this configuration, and there's more to it, but I want to, before we go any further, I'm going to type in do terminal monitor. Just to get terminal monitoring gives us console messages on the SSH session that I have going with this router, because I want to jump over and now do the call manager side of the configuration. I'm sitting in the Cisco Call Manager 6.0. Bring that over here right now. Need to log in. And as of right now, I'm going to go to the device menu, hit gateway, and I have no gateways configured. As I mentioned, I've wiped them all out, so there's nothing in there. So I'm going to click on add new, and I'm going to choose gateway just like we did before, 2801. That's what this guy is. Protocol, MGCP. And it comes to this base configuration screen. Now, one of the things you got to catch is the domain name. And I mentioned this is exactly the name of the router. So let me jump over to the router. Had my email flash up there. Jump over to the router, and here's my name, 2801 voice. And I'm going to come back over to the call manager, paste that in. Now, one of the things you have to watch out for is the domain name. When you're on the router, one of the things you do often, most of the time, is to enable SSH, is type in an IP domain name. I'll just do a show run including lines with domain. You can see domain name is home.local. So that is going to be part of the name that this gateway comes in registered with. It's the host name, which is 2801 voice, followed by the domain name, which is home.local. You want to make sure to put that one in there. If you don't have a domain name, you don't need it. You just put in the host name right here. But if you do, it's easy to forget, and it's going to give you hours of troubleshooting, wondering why this router isn't registering with the call manager. So I'll put .home.local in there and type that in. We've got that is the router domain name. I'll put the call manager group that just says what call managers are going to support this router. And that's, again, back in the CIPT. And then I'll just say the motherboard, the module is on the motherboard. The 2801 has built-in support for voice modules. So I'll save that. Now, it's going to pop up the subunits that I want to configure. And as of right now, the FXS port is sitting in module 0. It is 0, 0, 0, everything zeros. So I'm going to come back over here and say the subunit is going to be the VIC2 2FXS card. That's the exact model number of the card. I'll hit save. Pops up my port numbers, and I'll say 0/0/0. That's the one we just saw. I'm going to click on that, and I'm going to say the port type is, and hit the drop down, and I'll choose POTS, plain old telephone service. This is actually a new option they added in Call Manager 6. Before they just let you choose loop start or ground start, which is you can configure a phone using loop start or a connection to a PBX using ground start. But POTS is just a quick and easy way to set up just a plain old telephone service phone. I love acronyms that just have plain old in them. That's a great acronym. So I'm going to type in, hit next, and it comes up and says, okay, here is your port number. That's that identifier. What is your device pool? I'll just click default and hit save. And we've now, it says reset the gateway. That doesn't mean turn it off and turn it back on. It means that right here you want to hit this reset button, which reinitializes the connection. Let me add a phone number to that phone. And click on add a new directory number. And we'll just give it directory number 1500. I'll hit save. Comes up and says, okay, you've got the associated device. This is the port that's associated with that directory number. Last but not least, I'll just click on reset. It pops up this window to reset the gateway. It just reinitializes the connection. And I'm done with the call manager side. Now, there's one more piece I have to do we did the foundation call agent setup, but I now need to do the dial peer configuration. Remember I said we have to put that port under dial peer control. So I'm going to go back into the router, and I'll do dial peer voice, and I'll just use the extension number as the tag number, 1500 POTS, because this is a plain old telephone service phone. And I'll say for the port 0/0/0, and now this next command I'm going to type in is version dependent. Some versions of the iOS will have you type in application MGCP app, and it's case sensitive. The newer versions of code, and the one that I'm running, will have you type in service, and then it's MGCP app. Type it in like that. Enter. Now what that does, and I mentioned this when I first started the configuration, is it says this port is under or associated with MGCP control. Now I will mention that in the new versions of Call Manager and iOS configuration, this dial peer creation is optional. Meaning if you forget to create the dial peers, when the gateway registers with the call manager says these ports should be under MGCP control, and it will dynamically create these dial peers for you. It'll have funky, weird dial peer numbers like 999900000, just way out there dial peer numbers, but it'll just create them dynamically for you and save you some of the work. But that's real world. On the certification exam, you have to create the dial peers, right? So either way, the dial peers are necessary, whether you manually create them or automatically create them. Now the last command, or last couple. CCM manager config server, and I type in the IP address. What this is the TFTP server that has the configuration of the gateway. Just like Cisco IP phones, when Cisco IP phones boot up and register with the call manager, they download their configuration from a TFTP server that's on the call manager. It tells the phone what phone number it is. It tells the phone what locale it is. Actually, it doesn't tell the phone number. It tells the locale. It tells, like language the call managers it should register with, and all that kind of stuff. And in the same way, the call manager has a TFTP file, configuration file, for this MGCP gateway. When I went in and configured all this jazz over here in the call manager, it set up a TFTP file, an XML file that gives this gateway its configuration. So I need to point the gateway to the TFTP server, which happens to be the same IP address as my call manager. Last but not least, I'll type in CCM manager config, which says, okay, now go out, get your config from that call manager. And I'll hit Control Z, hit enter a couple times. I can see you see how it's lagging? That means something's going on in the background. Something's happening. Oh, look at that. There we go. Configuration by CCM is done. I didn't do anything to do that. It just, poof, popped up right there. So now, let me just do a show process CPU. I'm just curious. No, yeah, it's just curious, just from that delay in the prompt. I thought that the processor utilization probably hit a peak when it was doing that download. But it just downloaded its configuration from the call manager. Let me do a show run, including MGCP. Including lines with MGCP. Check that out. Remember, all I typed in was this, CCM manager MGCP. I typed in MGCP, and then I actually just typed in this, and the router added the rest of it. Remember I mentioned it, we would see that. But look at all this stuff. Blah. All these MGCP commands were downloaded or retrieved from the call manager configuration file that's on there. So we now have a complete configuration. In all actuality, I have a working phone. So let me bring in the rest of the story here. This is a live video shot. It doesn't look very live. Let me move it over. See, there we go. It's live. A live video shot of, I've got a Cisco IP phone which is being run by this call manager right here. Let me just go to the device phone, click on find. You can see I've got all these different phones right here registered with 172.30.104. So this phone right here is one of the phones that are registered with this, and right next to it I have this bad boy, the analog phone that this is the model here. It literally is garage sale material. It's just a piece of junk phone. I've got the cord of this phone running over to the MGCP port, or the FXS port on the MGCP router. So at this point, this phone should have a phone number, and it's been added to the call manager dial plan. It's part of that central database. So I should be able to go to this phone, hit speakerphone. Let's try it out. It's probably too soft to hear on my microphone. I've got one of those noise canceling ones, so I'll dial 1500 1500. You hear that? That's this phone. I'm putting it next to my microphone. That is the sound of a garage sale IP phone. So at this point, I can answer this phone, and the calls are linked. We now have an active call from this piece of junk analog phone, which is converted to a voice over IP device using MGCP and this voice over IP phone. And likewise, I can go to this phone, this analog phone, pick it up, and dial 2000 2000. And you can see behind me, the IP phone is ringing. It's receiving a call from this analog MGCP device, and I know that the light is blinding there, but it says from 1500 right on the screen. All of these things have been centrally added to the call manager dial plan. That's part of MGCP. That's what MGCP does. So that encompasses the foundation call agent setup. I know that's a big part of it, and the dial peer configuration. These last three configurations, I'm just going to, I don't want to say hit the high points because they're pretty deep, but most of them, like MGCP fallback, PRI backhaul, BRI backhaul, we're going to talk about in the upcoming nuggets in this series. Like PRI backhaul, PRI backhaul will primarily focus on when we talk about connecting to PBX systems, because that's most of the time where that's used. So MGCP fallback is where you want to configure the router to fall back on some other dial plan should MGCP fail, meaning it loses its connection to the call agent. Now there's different commands depending on what version of router. It seems like there's so many things I can say that for. Different versions of router have different commands. But in the older iOS versions, you used to, for MGCP fallback, to engage that, you would type the command call, I'll just scribble this up here, application alternate default. What that does is tell the router, and I know it's just scribbles, I just jotted up there quickly, call application alternate default. It tells the router if you lose the MGCP application. You remember when I set up the dial peer and I said application or service MGCP app? That's the MGCP application, and if you lose that application, it goes down. Your alternate You can use alternate processing as your default call processing. I know it's kind of a cryptic command, but if you don't type that command in, now that's on the old one, I'll type it in on the new one, but if you don't type that command in, as soon as it loses its MGCP call agent, the router just goes up, that's it, I'm done. Yeah, I might have some dial peers, but I'm not even going to look at them. I'm done. I've lost my call agent. This says you can alternate to another protocol for your default call processing. On the newer iOS versions, it's a little more complex. You go into global config mode and you just type in application. Enter. It takes you into this application mode. And then you go into a global command. You go into this global sub mode. And this is where you type in service alternate default. Enter. It's just, that's where the word comes in. Service alternate default. And that's where it's saying the default application will be something other than your MGCP service should you use that call agent. I know it's cryptic and it's strange to have to go into all those modes, but that is what allows you to switch over to some backup. Now what I can do is say, maybe I've got dial peer voice, we'll say 500 pots. For port 0/0/0, I've got the destination pattern 1500. So that's my backup. That's an H323 configuration right there. That would be a backup should the MGCP application fail for that phone. So that's the MGCP fallback. Now BRI and PRI backhaul. That's a big conversation. I shouldn't say configuration, but big conversation, because that has a lot to do with connecting to like PBX systems. Remember I talked about QSIG to start this video out. That's where you split the processing between the router handling layer 2 and the call manager handling layer 3. Now it's a big conversation because there's a lot of configuration that comes from the PBX nugget that we're going to talk about later. For example, I've got my another connection up here to a T1 voice router. I'll do a show controller T1. And I've got this T1 module installed inside, actually two T1 modules installed inside of this router that are VWIC cards. They can be used to connect to PBXs or the PSTN. So I can type in controller T1 and I'll just go under 1/0. Now, let me actually back up. I'm going to type in, it's slipping my mind, ISDN switch type. ISDN switch type, and we first, in order to set up a PRI connection, have to set the ISDN switch type either from interface or global config mode. And I'll say primary 5 ESS. Now, again, some of these commands I'm just going to bounce over to the PBX nugget. This sets what kind of signaling or switch type signaling it's going to be connecting to on the other side. That just has to match whatever the other side is. So I'll go now under that controller T1 1/0 and chop that up and make that a voice channel. I'll say PRI group and we'll say time slots 1 through 24. I'm going to use the full T1 line as a MGCP application. I'll say service MGCP. Hit enter. And what that does behind the scene is you can see all of a sudden, just throws all this stuff here, chops up all these individual serial ports. If I do a show IP interface brief at this point, you'll see that my router suddenly shows 24 separate serial ports that it uses for the voice channels, and those are going to be used for voice. Now, the big command that enables MGCP backhaul is I go under the D channel. The D channel on a T1 line is the last serial port here, or time slot 24 or channel 23, and I need to type in the command ISDN bind layer 3 CCM manager. That's Cisco Call Manager Backhaul. What that does is that adds that to the call manager configuration to where now all the layer 3 signaling on this is going to be sent to the MGCP call agent, which we configured in global configuration mode. So that is, I'll say, half of putting that serial interface under MGCP control. Well, I should say it's under MGCP control, but it's half of the configuration. The other half will come when we get into the PBX nugget, and I talk about implementing QSIG, connecting to the PBXs, and so on. The last piece is just DTMF relay. DTMF relay stands for dual tone multi-frequency. It allows you to relay all dial digits out of the bandwidth of the codec. So that way, anytime something needs to send dial digits, it can send it out of band. This is useful if you're using compressed codecs because they can scramble the tones and they won't be understood. So somebody will dial something and the call won't go through, or they'll connect and maybe it's one of those automated systems where it's like press 1 for sales, 2 for such and such, and they dial the numbers and it just doesn't work because the DTMF tones are being compressed. So to enable DTMF relay, we need to go to our router. And I'll jump back over here to the 2801 voice. We move to global config mode, and it's just a global config command, MGCP DTMF relay voice over IP codec, and you get to say, do you want to do it for all codecs or just the low bit rate codecs? And I'll say for all of them. Just to be safe, you might as well do it all. And I'll do the mode is going to be out of band. And there's plenty of other modes, and we'll mention some of these later on in the series. But this just says I will send them out of band to where it will not be included in the codec bandwidth, and that will allow you to send those digits to the call manager, to the call agent, without any kind of compression occurring. Lastly, I want to walk through some troubleshooting commands when you're working with MGCP gateways. One of these we've seen so far, and that is the show CCM manager. That's one of the most handy ones. Oh, let me get this back in here. When you're troubleshooting the gateway or troubleshooting the connection to the MGCP call agent through show CCM manager, it'll show you your primary and then backup, secondary backup, and so on if you have them. Now, if you configure them, they will be there and they will show up, and they'll end up showing up as what their status is. It tests the connection to them before the failover happens. So it's not like it fails over and it's like, oh, that one's not there either. It knows, so it will say whether or not that one is online or it's down or something like that. You can see right here the call manager it's currently active with, if it's failing between the three. And then down here, this is the main connection information. It shows how many successful attempts in downloading the configuration you have, and you can see if it fails and so on. If you're not communicating with them, you'll start seeing the failures of the download ticking up quite a bit, and that will give you some clue that, hey, there's some kind of communication mismatch. Maybe I didn't specify the domain name right. Maybe it's a name mismatch, or I didn't include the domain name. All those things could be possibilities, but this is usually the first place to check on Call Manager registration. Now, show MGCP is going to be a dump. All kinds of stuff of MGCP. You can see what it's currently active, shows what port number you're registered with on the call manager up there, the IP address. It shows what modem pass-through that you're using. You can see G711 ULAW is the codec that you're using for that, the gateway port that you're using when you're communicating. Just a dump of everything MGCP. So if you're looking for some MGCP stat, it's probably in there, probably somewhere in that MGCP show MGCP command. This one's pretty simple. Show MGCP endpoint, and that'll just show you which endpoints are registered with MGCP. So if you're curious, well, what's showing up here? You can see right there's our analog line, and we can go over to the call manager and make sure that this one is showing up there, and that kind of shows which ports are configured for MGCP. Show voice port is another dump command. I usually do the show voice port summary. That's this guy. But just show voice port dumps all kinds of information about every single voice card. Like you see, 0/0/0 is a VIC2 2FXS card. It's part of that voice part. Then down here you can see all of the echo cancellation, input and output, gain and attenuation. That's if you're increasing or decreasing the volume on it. You can see the connection. Again, just a ton of information to weed through. This is primarily where you'll go when you're trying to dig for some information that's not obvious in the configuration. The last one, show MGCP connection, is pretty cryptic. It shows the active connections, which right now there are none. So I'm going to pick up this analog phone, dial the IP phone next to me, lift that one up, and do the command again. And you can see it. Whoever made this output should just be fired at Cisco. It's like, let me just dump some ugly stuff and let you weed through it. It pretty much it shows right here, here's the endpoint. It says call ID C, connection ID I, port is P, M is mode. So then, it's giving you this little code, and then right here it shows we have one active call. It's on this line right now. C, the call ID, is this. That's to MGCP how it identifies the call. The connection ID is 0x5. That's some internal identifier. What port number it's using for that. What mode it's using. So you go, okay, M equals 3, and then you have to go, okay, the legend for the mode is 3 is send and receive. So we were sending and receiving audio on this call. You see what I mean? It's like, come on, you could have made some kind of easier output than that, but that's what you got. So that's if you really need to dig into what the active calls are in MGCP, you can use that command and weed through it to find out exactly what those settings look like. All right, I know this one has been a little bit longer, but there was just a lot of stuff we had to get through in the configuration of MGCP. So let's wrap up. We saw the concept of MGCP backhaul to start things off, which is the splitting of layer 2 to the router and layer 3 to the call manager, typically for ISDN PRI lines, where you split that processing, most of the time used for QSIG configurations to PBX systems. We then saw the port descriptions and how MGCP comes up with a little bit cryptic of a name that gives you the module, unit, subunit, port number for every single module that you're looking at, and you're now able to recognize and identify what port that is by looking at the description. And then finally we looked at the configuration and troubleshooting of MGCP, working through each one of those scenarios to configure an MGCP gateway. I hope this has been informative for you, and I'd like to thank you for viewing.